Hello class, in this video we will talk about the topic similar triangles and circles. So as it implies, we have a circle and we have existing similar triangles in this case. So let's move with our first theorem. It's called two tangent segment theorem. So literally there are two tangents here from the same external point. So AG here and AT drawn from the same external point A from a circle, of course, the same circle. And the idea here, class, is very simple. The two tangents measures will be equal or congruent. And this angle here formed when you draw this segment from the center to that external point will also be equal in measure or congruent. And that's it. So let's use this theorem. So what is x and y? Of course, let's solve one by one. Let's try x muna. So we have here x. So how do we solve that? So 3x here represents the segment. So let's apply the segment idea of the theorem, all right? So according to the theorem, the two segments must be equal in measure right there. So AG equals 80. Simple as that. We will substitute. And what do we do next? To solve for x, of course, we divide by 3 and we get 18. So simple as that, class. We have x equals 18. Again, we can review. 3 times 18, yes, that's 54. So check. Do not forget, class, to always review your work. Now let's proceed with solving for y. So we have here 2y and the other is actually 26. So according to the theorem, the two measures are actually equal or the angles are congruent. So we have here the measure of TAC equal to the measure of GAC. And substitute, divide by 2, we get 13 degrees. Again, we can confirm, we can review. 2 times 13, yes, that's 26 equal to the other one, which is also 26 according to the given. Okay, very good, class. That's it. No? Do you have any question? Of course, there is no comment part here, but I believe you can always ask me online or in any way possible. So let's move forward to the second theorem. We have here the intersecting chords. Again, very literal. We have two chords intersecting in the interior. Okay, so what's the idea here? So if you read that, it's very simple. The product of the segments AJ right here and TJ and at the same time GJ and JH are actually equal. So let's use that idea to solve problems. Say we are going to find the value of x here given all these. So again, to solve for x, we apply the intersecting chords theorem, a very simple idea. So we just multiply the segments and these products are equal. So AJ times GT equals GJ times JH. Oops, sorry. And again, from there, we can just substitute. Now listen carefully. What I'm gonna do here is I'm not gonna multiply to avoid getting big numbers because I don't like solving my equations with bigger numbers. Sometimes I really become more erroneous when I do that. So I will cancel first. So right here, listen carefully, 10 and 20. I can cancel this by 10. That leaves me 2 and 1. Just divide. Canceling just means divide common factor. So in this case, 10. That's 2 and 1. And again, 2 here and 12. I can cancel that. So that's 1 and 6. And again, 2 here and 6. I can cancel that. That leads me x. Again, be careful if you don't understand, if you don't have any idea of what is cancellation. I suggest you study more, you review on what situations you can apply cancellation. In my case, we can all apply cancellation here because both of the sides of the equation are all just multiplication. So cancellation is very applicable all throughout from the first to the last step. We can confirm if x is really 3 by multiplying to 2. So that's 6 times 20. Yes. So the product of these two segments is 120. And if you multiply the other segments 10 times, yes, that's also 120. That confirms that x must be 3. So again, do not forget class to review, all right? Okay, let's move forward to the third theorem. So we have here 2-secant segment theorem. So this theorem, of course, literally you have 2-secant drawn from the same external point towards, of course, a common circle. So say HS, HU rather, and HG. These are the seconds. And what's the idea of the theorem? So the idea of the theorem is that if you multiply the segment right here, say UH and its external part right here, it will be equal to the other second. So that be HG times its external HA or AH. So they are equal, as simple as that. Nothing to bother. So we will now apply that with this problem. We have to solve for W class. So how do we solve for W? Are still there? Of course, you're still there, no? So we have here W and 10, 8, and 7. So again, according to the theorem, we will just multiply the second. So in this case, HG and the external AH for the other second. So UH, right here, UH or HU. and the external SH or HS. So simple as that. The product of the external and its secant is equal. So substitute. So note that AH is 10. And why is GH W plus 10? Well, G here, GA is W, AH is 10. So add that. That's W plus 10, no? So same goes for UH. UH is 7 plus 8, so that's 15. And the external is just 8 right here. So from here, I can only cancel 10 and 8. So again, cancellation requires mastery. It requires previous knowledge. You cannot just cancel everything. So right here, I cannot cancel because there is addition here. So unlike the previous examples, but I can cancel here 10 and 8. So you have your 5 and 4. And from here, I can cancel 5 and 15. That leaves me here W plus 10. And right here is 3. So from here, I can now multiply 4 and 3. That's 12. And we can transpose this minus 10 here. That becomes 2 on the other side. So W rather other word is 2. So let's confirm 2 here and 10. So that means it's 12. 12 times 10, 120. 8 times 15, yes, that's also 120. So again, check your work to avoid wasting your efforts. And last but not the least, the fourth theorem. So again, literally tangent-secant segment theorem. You guess it right. We have a tangent and a secant from the same external point towards a common circle. So what's the idea there? Very simple. If you read this theorem, the idea is just if you square the tangent, it's just equal if you multiply the secant and its external parts. So the secant here is AS or SA, and the external part is HS or SH. So that's it. Square the tangent. So ES squared or SE squared. Very simple, right? So let's continue. So let's solve for E. So this is E, this is 9, and this is 12. Again, very simple. The idea of the tangent-secant segment theorem. So we will just use the theorem to create this formula. So again, this is the external part of the secant, and this is the secant itself right here. And right here is the tangent. You just square that. So do that. That's it. So be careful with your solution. Apply your GEMDAS and all your possible knowledge and skills. So again, we have here 9 for HS, and for AS, that's 9 plus E, right? And for ES, that's 12. And we square that. That's 144 right here, 9. So from here, I cannot just cancel everything since there is addition here. So I'll be careful here. Again, I should have prior knowledge or mastery of using cancellation. I cannot just cancel everything. Be careful. If you don't know that, you just use multiplication and distribution and everything. But for me, I can use cancellation for 9 and 144. So this becomes 1. Right here becomes 16. So I cancel these two using 9. So 144 divided by 9 is 16. So let's move forward. So I can transpose this here. That's minus 9. So E here is actually 7. So is it true? So 7 and 9. So 7 plus 9, 16 times 9. Yes, 144. And 12 squared is also 144. So that confirms that E class must be 7 for the theorem to be true to this um, example, since we have here a scenario of a tangent-secant segment theorem. And that's just it, class. For summary right here, this is your summarized theorems for the topic. And again, the topic is similar triangles. You might not know that, but there are actually similar triangles there. In series, maybe I'll make another video of this just to show you where the similar triangles are. And that would be it for this video. Thank you so much, class, for watching. I hope you have learned, and I hope you will have the best of the coming minutes or hours of the day.